Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks problem of the day, and today's problem is Symmetric 3 and it is an easy level problem. So this problem is much similar to yesterday's problem of the day, and again a very good example of why you should not overthink about recursion and why recursion should be broken down into steps to make the problem easier. Right. So let us see what the problem says. It says that we have been given a binary tree and we have to check whether the tree is symmetric or not. Right. And we have to tell that means symmetric means that the binary tree is a mirror image of itself or not. Right. So basically this is the tree. This is the tree. Right. So I have to draw a mirror image in this particular line. I'll give you a better example. Let me just take this. So if I take this example here, now I'll have to draw a straight line. So this is going to be my mirror image, right? This is my mirror and my tree has to be symmetric across this mirror. So now this problem is not exactly recursion, but somewhat very similar to recursion, similar to what we do, right? So how do we actually do this? What we can do is we have this particular node, right? We have some nodes to the left, some nodes to the right. So for the initial node, it passes exactly through the mirror. So we don't even have to check anything for that particular node, right? What we have to check is the subtree that is present to the left of it symmetrical to the subtree present to the right of it? This is what we essentially have to check. So let's say we have some more nodes. Here are very few nodes. So let me just draw some more. So let's say this was the tree and this is, let's say, 1, this is 2, 2, and this is 3, 3, 4 and 4, right? So this tree is also going to be symmetrical across this particular line, right? So I have to change it to 4. Now this is symmetrical. So what is essentially happening is this particular node is closest to this particular node and it is equal. This node is the counterpart of this node and these are equal. And again this node are counterparts of each other and these are equal. So let us first start with the root node. So what I want is the left of this particular node is equal to the right of this particular node. For the root node it is very easy, right? So let's just say we have this particular node A and this particular node B, right? So we want that A is equals to B, only then our tree will be symmetrical. Now these A and B have further nodes as well. So this A has some left and right node, similarly B has some left and right node. We want the left of A to be equal to the right of B, and we want the right of A to be equal to the left of B, right? So that means here A and B were like this. Now A dash will be equals to A dot left and B dash is going to be equals to B dot right, right? Similarly, we can also write A dash dash as A dot right and B dash dash as B dot left, right? So once you have these will be your new A's and B's and you have to perform the exact same thing again, right? So this is how I meant it was actually similar to recursion, though in this particular problem I have implemented it using a queue. You could have also used recursion again, there is no issues. You could also use recursion, but I have implemented this particular problem with the help of a queue so that you get to know a different idea as well, right? So what we have here is a simple condition that the current nodes should be equal and the children should be equal in such a way A dot left should be equals to B dot right and A dot right should be equals to B dot left. This is the only thing that you need to know and the rest of the thing will always follow. So how could you have observed this particular thing? You could have drawn a very small subtree like this, and in this particular tree you can observe that A dot left is actually corresponding to B dot right and similarly A dot right is actually corresponding to B dot left, right? Now the rest of the thing will automatically fall into place if you implement this particular part correctly. So let me show you my summation. So I'll just move it into my editor. Yeah. So here you see what I have done is this is same function is exactly copied from my yesterday's summation. I have used the same function And here what I do, how to check whether two nodes are equal or not. I do, first of all, if only one of them is null pointer, you see I have an XOR condition between them. So if exactly one of them is null pointer, I am going to return false, right? Now if I come here to this particular return statement, that means either both of them are null pointer or both of them are not null pointer. So this particular first condition is going to take care of the case when both of them are null pointer and it is going to return true. Now I have a logical OR in between. If this is false, then this second condition is going to get evaluated and this will show that both of the data are equal. So either this will be correct or this will be correct, right? Only then this is same function is going to return true, right? So this is what we do here. Now we come to this asymmetric function and I check whether if my root is itself null pointer, I am going to return true. Otherwise, I am going to form a queue, right? Now in the queue, I push the left and the right of the root node, and I have a OK variable which is going to store whether my tree is symmetric or not. Now I again have these left and right variables. These are going to be pointers and these are going to represent the A and B pointers that we were discussing right now. So while OK, that means while my condition is true or the tree is still symmetric and my queue is not empty, I'm just going to perform this particular operation. I am going to get those A and B pointers in from my front of the queue and I pop the element from the queue. Now I have this OK variable and I check whether these nodes A and B, or here I've written them as left and right, are equal or not, or are they same or not, right? If they are same, only then I'm going to proceed further. You see I have this particular condition OK and left. So OK will tell me that the tree is still symmetrical and this particular left is going to tell me that this left node is not null pointer, because in the next step I am accessing the left and the right child of the current pointer. If the current pointer is itself null pointer, these two statements is going to give me some error, right? That is why I have to check whether that node is null pointer or not. So if it is not null pointer, I am going to push two new things into my queue. So these are the new conditions that I have to check. What are those conditions? That a dot left or left left should be equal to right right and left right should be equal to right left. So this is exactly what we discussed here, that the new A should be equal to A left and the new B should be equal to B right, and these two should be equal, right? So when I push them together into the queue, you see in the next step they will be evaluated if they are equal or not, right? So once all of this loop has been completed, I can return my OK variable which is going to store whether my tree is symmetrical or not, right? So this would be the solution of this particular problem. Again, you see that the idea is the same. We are not explicitly solving the whole problem. We are just solving a single step and pushing the further steps into the queue, right? So the queue will take care of all the other things, and this is the way we can solve this particular problem. I hope that this solution was helpful for you, or this video added some value into your knowledge. And that is it for today. If you guys enjoyed this particular video, then do consider dropping a like and sharing your thoughts in the comments, only because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.